Hey everyone, so I have a problem. I have this aim logger over here and I need to mount it in my car. And I don't know where to put it. The catalyst sits over there and my aim solo used to sit like right here. However, this is facing up. So my idea is to kind of mount it somewhere like this. The problem is no one makes a mount for this, so I'm gonna have to make it myself, which is fine. That's what this video is about. So the first question is, do I really need to make something myself? You can see that I have tape here. Maybe not the strongest, but it is tape nevertheless. And I'm asking this question because you can always tape stuff to stuff for like mounting purposes. You can screw stuff in. However, in my case, one, I want to make a video about this. Two, I have another problem. And the other problem is, you can see this is not quite level. And I noticed that when I had the data pulled up in the aim race studio, my lateral G's was like below 0. And I was like wondering why. Until I took this guy and I put it like, you know, sideways, upside down, and whatever, right? So the lateral G's is going to be 1 when it's on its side because the earth, gravity, blah, 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 right? And then the longitudinal G's will be 1 when it's kind of like this way. So I want to mount this like this, but I need it to be flat and I need it to be level. So that's kind of why I'm making a mount. What we're going to do is scan this area and see how we can figure out mounting. But you can see one obvious problem is we don't really have anywhere to mount stuff to. So two things I can do is I can create something that uses like VHB. Also, that's like the tape. And kind of just mount something here, and then I could have like a plate here, which is magnetic. And then I could just, you know, click that in. I think that's going to be similar to what my solution is going to be. My other solution could be I drill holes somewhat here, maybe in the screen area. I know it sounds scary, but it can work. And then I will just create something to mount into those holes so that, you know, we have like a solid base and it's just permanently going to live here and I can just always mount this. But either way, yeah, we got to figure out a mounting solution. And the first step is to scan everything you see here. All right, I just sprayed the interior, not the entire interior, but I have this, whatever this is called, and it works well. It's cheaper than the blue stuff, which is actually better, but it's more expensive, and I just need something that works. This is what it looks like after scanning, and that's the level, which I will explain in a second. It's extremely crucial that you pay attention to what you're scanning on the screen, so it's probably even better to look at the screen than it is to look at what you're scanning. So you can see with the scanning spray, it's just so much easier to grab it. But we have this black section in there that it's not really grabbing. And we kind of do need the data for, so I will go and respray. The spray is in, it's, you know, very white now, so let's continue. So once you get a match, yeah, so that's great. So you see how it's capturing a lot of that section that was missing. So I have this level here because of two things. One, it helps to have a reference for alignment. You see it's having trouble with the flat parts. Intro to scanning. So I'm just going to put an object in between A and B. So I have this guy over here because when I want to do a scan, you need an object to easily align to, you know, X, Y, Z plane. Amazing. And then specifically for this is basically a level telling me that this is kind of at 0. And I want my plane to be 0 so I can zero out the mount. So I'm going to use this as a reference point. But let's go get something to put here. All right, anything is going to do. And we see that we have our original scan area. And now we just need to scan this guy in. So once again, this is the difficult part about scanning. It loses reference very quickly. So I am going to try again with more preparation. New scan. So same settings, preview, and then I'm just going to spray more of this stuff. All right, so we're gonna start with the new scan and just added more things in the way. And in fact, I'm gonna start here so that it captures it well. So see how it's just well captured, but the surface on the bottom is just not being captured properly. But this, I think we're good. The pen is also captured. And what we really want is this. I don't trust that it's actually going to be able to properly capture the front, because the front is extremely reflective. And again, you know, it sees the knob, it sees the sticker, but it doesn't see the reflective glossy front, which is fine. That's not what we're here for. But as long as we have this and we have that, then I think we're good. All right, so we are in MeshMixer right now, and this is going to be the program that we do two things before we go into Fusion 360. We are going to align the entire scan because you can see it does not look good. And then we are going to reduce the mesh so that Fusion 360 doesn't choke. So I did mention that I use a .ply, that's, or PLY, however you want to say it. I think it contains much more vertices and just information. We do not want that much information because what we have here is pretty simple. So the first thing we want to do is essentially select all. So Control A and reduce. I'm just going to hit it around here. All right, so the next thing we want to do is align. We have the scan over here, and we want to go to Edit, Align, and then we want to start by clicking a point that we know is facing up. So here, for example, sometimes you might need to flip or rotate. So I'm just going to flip it, and you can see that we have this guy pretty much facing the right way. So I'm going to accept. And then the next thing I want to do is align, let's say another axis, but you can see here that we're not quite straight. And the reason we're not quite straight is because each of these points or triangles or vertices isn't exactly smooth. So this is kind of why you might also want to reduce your mesh size. But here I'll just do the same thing again until it looks straight with, you know, the naked eye. And this is kind of where some of that variation can come in. Okay, so that looks better. Now we want to do another side. We would want to change the destination. All right, so in this case, I selected the side of this object over here. So that's this guy. And kind of like doing the same thing, we just want to select a very flat side. And we can see that once we are ready to commit, it kind of corresponds to making it straight along this angle. So let's click OK, and yeah, that's pretty much what we get. So yeah, this is the quickest way to pretty much align your scan, and I do encourage everyone scans with like a XYZ cube to make this part really easy. Next thing we're going to do is export, and just export this in whatever you want in the object format or OBJ format. Welcome to Fusion 360. The first thing that you want to do is draw out or sketch out your basic design. So what I did here is I want to use a base plate, a magnetic base plate, and have it attach into the final object. So this is what the final object is going to look like. You first start with a sketch. This is going to be just a simple square, which is going to be the dimension of what I want the base plate to look like. You will draw a center diameter circle, and then you will use a rectangular pattern to essentially pattern this out. And then I'm going to be using 2 magnets that are 12.8 millimeters each. You can use whatever magnets you want at this stage. I just chose this because I thought it was going to be strong enough. Before we move on, I just want to say that you should probably use a lot of parameters because the reason that I did this first is because I want to test fit my initial design without fully designing everything first. And so you're going to see a lot of parameters over here, and that's just because I had to adjust the size of the circle. I had to adjust the size of the magnets for it to be like a nice press fit. I had to adjust the size of the base plates, and you're going to see that, it's 55 by 55 here, but this is not, it's 42 by 43. And, that's kind of by design of the device that I'm trying to fit to. I will say that for the most parts, most designers are not sadists, and so they would use nice round numbers. So in my case, 42 by 43 just seemed to work for me. The next step is to insert mesh. You would go to the top and go to insert mesh, and then you should be greeted with a dialog to essentially do that. And it's pretty much this easy since you already did the hard work of the alignment in the past. You just have to hit that 90 and then you're good. See, it fits. The next step is to go to the mesh tab over here and then create mesh section sketch. And what that does is allows you to create basically a line in whatever axis you want of the sketch. And you can see I already have a line created here. And then I'm going to have a few more lines created in other places. And what this is doing, so second line is here, third line is here. And the reason I'm doing all this is because I want to attach my receptacle to a nice solid area. So I have kind of like the bounds of what I want to attach it to. So I know that this is a nice flat area between this line, and then same between this line and this line. And so I can just plan around that. Okay, so once you have the sketches of your general profile lined up, you can see that this makes out the key places that we want to place our item. Once you have that pretty much set up, then the next thing that you want to do is go to one of these sketches. So let's go here, for example. And normally you could use this button in the Create tab called Fit Curves to Mesh section. You can define the curve from start points and the end points. So let's do something like this to this. And it essentially creates a curve spline that will match that. The problem is, again, since scans are both precise and imprecise, it will match, every single undulation. So we don't necessarily want that in this case, at least. So what I did here was I just drew straight lines. Actually, I added points here. I had a point here, I added a point here, and to the bottom, and I just drew straight lines. And then I just connected the lines. Once you do that enough times, you essentially have kind of like a table that you can kind of visualize. You can visualize that plane through these. And that's exactly what we're going to do. Here, I'm going to construct a plane through 3 points. And my 3 points are going to be this point, and this point. And you can see that it pretty much lines up. All right, so you can see that once we construct our plane through those 3 points, we essentially have a plane that goes kind of through the top, and this is where we can actually start to make drawings. And we can just repeat this for the downside, and we have another plane. So now we have a plane on the top, we have a plane on the side, and we can construct sketches on the top plane or the bottom plane. And you don't even have to do the lines as I did in this case. You can just do the mesh section, put a point here, put a point here, put a point there, and just create a plane. The rest of this is going to go by rather quickly. Since we already have our planes, everything else should be relatively easy for us to finish up. So I just made a couple of sketches here, kind of mirroring the top portion of the dash and doing the same for the back. And since I want the X log to be mounted kind of somewhere around here, I will just, create something that looks like what I want to do. So I also 3D printed this out while I kept designing. So I think that's one good thing about 3D printing is that you can prototype as you go. So as I was going, I prototyped a piece of this, and here we are. Luckily for me, I did have access to the step file of the X-Log. I just moved that around to be in a location that I felt like it should be in. And you don't need the actual device, you just need maybe like the bottom surface of this just to figure out where you want to actually place the device. So you can see if I am in my car, I want it to be somewhat straight. And this just lets me know that I'm going to have to create something that goes from here to here. So what you can do is just create another plane, which is this guy over here, and then sketch the bottom side of it. And then once you sketch the bottom side, you can just extrude it down to your base feature, which we already designed. And from then on, you pretty much have what you want. And now it's all about designing in all these features and, possibly making it look pretty. So what does that look like? You can see that I'm just cutting off edges that we don't need. Just trimming stuff out from the back. Adding a rib so this can be strong, and adding fillets. And yeah, this is pretty much the final product. If you want to see it look, a little nicer, you can go into render. And yeah, so this is what the final product looks like in render. So next thing to do is just to 3D print this. If you're watching this video, you probably already own a 3D printer, or you're going to own one soon. So I would just 3D print it. For the test piece, I put 2 holes at the back so that I can always pop these magnets out, because sometimes when it fits too well, you can never get the magnets out. And then the next piece was going to be printing something like this, so you know how it fits. It's a little loose, so we have to fix that. And then the second thing I noticed with this print is the orientation of the print. So I think I tried to print this upside down, and you can see it's kind of ugly. So we want to fix that. With this print, I think it looked good, but then I noticed a mistake was the hole over here was missing, and so that's just no good. But the overall print looks much, much cleaner, and we can move on to a rough final draft. So I wanted to print this in carbon PETG because it's in the car, carbon because carbon prints better, it looks great, and well, it's carbon. So the final design is installed, and you can see that's the 3M, and this is the actual design. The top is beautiful, and the actual placement is great. It's pretty sturdy, and the best part is, listen to that. It just locks in. So it locks in almost too well. But this is how we go from basically nothing to a product that you can pretty much sell to other people who have the C8s, the X-Log, track their car, and want this specific solution. And if you notice, the magnets are hidden. There's lots of tutorials on how to do this, but they're hidden on both sides, which is cool, as you can never tell.